Imagine that you have the power to cut a piece of aluminum foil in ever smaller pieces. You will cut the piece in half, then cut it again, but in quarters, then again and again. Do you think that you will ever finish this stack? That you will eventually end up with smaller possible pieces of aluminum foil? Do you think that the stack has no end?
An atom is a fundamental piece of matter. Matter is anything that can be touched physically. Everything in the universe except energy is made of matter, and so everything in the universe is made of atoms. An atom itself is made up of three tiny kinds of particles called subatomic particle, protons, neutrons, and electrons. The protons are the neutrons make up the center of the atom called the nucleus, and the electrons fly around above the nucleus in a small cloud. The electrons carry a negative charge and the protons carry a positive charge. In a normal neutral atom, the number of protons and the number of electrons are equal. Often but not always, the number of neutrons is the same too. Carbon atom has 6 protons, 6 neutrons, and 6 electrons. Magnesium atom 12 protons, 12 neutrons, 12 electrons, and a calcium atom 20 protons, 20 neutrons, and 20 electrons.
Unfortunately, Aristotle and other well-known Greek philosophers did not agree with Democritus' ideas about atoms. If matter is composed of such particles, they asked, then what holds these particles together? Why does matter not fall apart, the way sand castles fall apart in the wind? Democritus could not answer such question until 17th and 18th centuries. These years ushered in a new way of dealing with nature, one that relied not merely on logic but also on observation and experiments.
There are two significant discoveries in the principles of chemical behavior. The number one is the law of conservation of matter, that Antoine Lavoisier carefully measured the mass of substances before and after a chemical reaction. He found out that the masses were always equal and the chemical reaction doesn't create or destroy matter, but the matter conserve. The second law is the law of constant composition by Joseph Louv Prout that he was a French found out that a given pound always contains the same elements in the same proportions by mass.
Atomic theory of matter. In 1803, a modest English school teacher named John Dalton studied these experimental observations. Dalton concluded that the properties of matter could be explained in terms of atoms. Dalton's atomic theory of matter was based on the following postulates. Each element is composed of extremely small particles called atoms. All atoms of a given element are identical, but they differ from those of any other element. Atoms are neither created nor destroyed in any chemical reaction. A given compound always has the same relative numbers and kind of atoms. Atomic theory is a scientific theory of the nature of matter, which states that matter is composed of discrete units called atoms.
Can we be sure that the atoms exist? We can come close to actually seeing an atom thanks to a device called scanning tunneling microscope. It can provide us pictures of atoms. There are about 100 elements, which means that there are 100 different kinds of atoms. The atoms combine to form each of the vast number of substances that make up the world around us. And that means that yes, the atoms indeed exist.
You can look at chemistry as the study of two worlds, the macroscopic world and the submicroscopic world of atoms. Chemists make their observations in the macroscopic world, the one in which we all live. However, in order to understand that world, the chemist's goal is to understand the atoms that compose it. So many of the scientific achievements of the 20th century, deciphering the genetic code, designing plastics, understanding the ozone hole, and imprinting data on a silicon chip, to name only a few.